Hello all, welcome back. I am A.Bharath Vamsi and now I will explain about arithmetic coding in detail. Arithmetic coding is one of the methods of image compression. First, let us think about image compression. Why image compression? Consider an image of 1024 x 1024 pixels. To store it, we need around 3 MB, and for a video of similar resolution, we need around 2 GB, which is huge. So, we need to have a proper representation to store it in minimum number of bits without losing the character of the image. Image compression consists of two components, an encoder and a decoder. Encoder performs compression and decoder performs decompression. Here, f of x, y is given to encoder and f cap of x, y comes out from decoder. In general, f cap of x, y may or may not be an exact replica of f of x, y. If it is, then it is error-free or lossless compression, and if it is not, then it is lossy compression. In arithmetic coding, one-to-one correspondence between source symbols and code words does not exist. Arithmetic coding output a probability value between 0 and 1. Let us consider an example to illustrate the procedure. Initially, the message is assumed to occupy 0 to 1. The table shows the interval is initially subdivided into 4 regions based on the probabilities of each source symbol. Now coming to the procedure, firstly we divide 0 to 1 as per the subintervals given in the probability table. As the first symbol is A1, the region corresponding to A1, that is 0 to 0.2, is expanded as a whole, and this region is divided as the same ratios as we divide 0 to 1. And as the second symbol is A2, we expand the region 0.04 to 0.08 as a whole and divide them as per the ratios, and this process continues till we reach the last symbol. At last, we get the region as 0.06752 to 0.0688. Any number within this interval represents the message. Let's consider it around 0.068. In arithmetic coded message, 3 decimal digits used to represent 5 symbol messages. Let us consider another example of encoding Bill Gates. These are the probabilities or frequencies of each character, and this shows the range of each character. We do the same process of narrowing the ranges till we reach the last character. And then we choose any number between this range that will uniquely encode Bill Gates. In this case, this value will uniquely identify Bill Gates. In extension to arithmetic coding, we have adaptive context-dependent probability estimates. Arithmetic codes are near optimal due to accurate input signal probabilities. Whereas in Huffman coding and Gulam coding, the results are non-optimal due to inaccurate probabilities. And in order to increase the accuracy of probabilities, we use adaptive context-dependent probability models. Adaptive probability models update symbol probabilities, whereas context-dependent models provide probabilities based on predefined neighborhood of pixels. These adaptive and context-dependent probability models are used in most of the image compression standards like QCoder and MQCoder. Adaptive context models also used in Gulam coding. The block diagram shows the steps involved in adaptive context-dependent arithmetic coding of binary source symbols. The context of input symbols are formed in the context determination block. These 3 blocks show 3 symbol possible contexts, and for these 3 contexts, the probability estimate blocks are 2 power 1, 2 power 8, and 2 power 5 respectively. The appropriate probabilities are then passed to the arithmetic coding block as a function of current context. The probabilities associated with the current context are then updated as another symbol being processed. Though arithmetic coding gives near optimal codes, but most implementations support Huffman coding due to some United States patents. Both arithmetic and Huffman coding have their own advantages, like arithmetic coding has more compression ratio, while Huffman coding needs less execution time. Thank you.